Alrighty, in this video we're going over quadratic optimization. So it's a similar process to worded problems, but only we're trying to find a maximum or a minimum this time rather than like an x-intercept. So the key formula we need to use is that the vertex happens at minus b over 2a in a quadratic formula. So if your equation looks like ax squared plus bx plus c, it would be minus b over 2a, which is the vertex. Okay, the other fact you need to know is that the maximum or minimum is always in the middle of the two x-intercepts. And that's what I mean when I say the word vertex. So like the vertex is this highest or lowest point on your quadratic, depending which way it goes. So let's do this one. Find the minimum of y equals x squared plus 2x plus 3. So in our case, a is 1, b is 2, and c is 3. The vertex equals minus b over 2a. So that is minus 2 over 2 times 1. In other words, that's just minus 1. So that's the x coordinate of the vertex. Now if we want to find the y coordinate, that's going to be subbing the x coordinate into this equation. So minus 1 squared plus 2 lots of minus 1 plus 3, which is going to give us 1 take 2 plus 3, which is I think 2. Okay, so the vertex is at minus 1 comma 2, and we can actually check that using a graph. X squared plus 2x plus 3. You can see the vertex there is at minus 1 and 2, and that is the minimum value. Alright, so I guess that 2 technically would be the minimum value because that's the lowest value that the function has. Alright, next we're going to find the maximum value of this one. So for the vertex, x equals minus b over 2a, which is going to be minus 5 over 2 times minus 2, which is going to be minus 5 over minus 4. Which is going to be 1.25. There we go. So if x equals 1.25, y, we just plug in minus 2 brackets 1.25 squared, plus 5 lots of 1.25, plus 1, and then we can see what that is. Minus 2, 1.25 squared. Plus 5 lots of 1.25 plus 1 gives us our y value 4.125. And in fact, if you had that graphed on your calculator already, you could actually use the trace button to get your y value as well. That would be a bit quicker than typing in like this. Anyway, 4.125, and let's just check that. Minus 2x squared plus 5x plus 1. Go, and it looks like we've got that right. So that's our maximum value. So the vertex is at 1.25 and 4.125, and then that would be our max value. All right, so the real thing that you do in these questions is you do worded problems. That's the main point of doing these optimization ones. So a gardener has 40 meters of fencing to enclose a rectangular garden plot. Now one side is an existing brick wall, and we're going to suppose that 2 new equal sides are x long. So what that's going to look like is we've got this wall here, and then you've got this rectangular garden where they're the same and they're both x long. And we got 40 meters of fencing to use all up. So total fence equals 40 meters, just like that. All right. So we've got to show the area enclosed is given by that. So this is sort of a multi-step problem. We could sort of like call that bit y. So let y be the width. Then we know x plus y equals 40 because this is the total length. So that tells us that 2x plus y equals 40. So, well, y is going to be 40, take 2x. So that's good. And then basically what you can do there is rather than referring to this thing called y, you can just have your wall. And then that's x on the sides, and it's 40, take 2x on the top like that. So therefore area, which is length times width, equals x lots of 40, take 2x. Which if we expand that out is 40x take 2x squared once we expand it out, and I think that's what they wanted. Actually, no, they didn't want that. They just wanted the factorized version. So that's actually kind of fine. So that's good. There's our area. So what we can do now is we can find the vertex. So there's a couple ways we could do this. Right off the bat, I can see what my two x-intercepts are. So on part B, my x equals 0 is an x-intercept. And if I think about this one, x equals 20 would be an x-intercept. So the vertex is halfway in between those. So that's going to have an x-coordinate of 10. The other way that you could do this is you could expand it out. You could go 40x, take 2x squared. So that would tell us a is -2 and b is 40 and c is 0. So that tells us the vertex has an x coordinate of -b over 2a, which is -40 over 2 times 2, 2 times -2, which becomes -40 over -4, which again is 10. So whatever way you want to do it, the vertex has an x coordinate of 10. Now to get the area, we're going to go 10 bracket 40 take 2 times 10. And that's plugging the 10 back into that equation up there. So that's going to give us 10 times 40 take 20, which is 10 times 20, which is 200 meters squared. Then you basically just want to give a sentence answer. So dimensions of the garden which maximize area. Area is maximized when x equals 10 meters. So that's going to look like this. It's always good to draw a picture, 10, 10, and 20. And the max area is 200 meters squared. And you can actually get that from Desmos as well if you want. So x bracket 40 take 2x is our function. There we go. And then we're gonna do that. And you can see we've got this maximum here at 10, 200. So the x value would be 10 and the area would be 200.